Hey, good afternoon, everybody. Welcome to our third webinar for our Lubruary. It's been a great month so far, a lot of participation. So clearly these are topics that are hitting home with folks and something that you all enjoy hearing about. So we're happy to share our third presentation with you today. We've got Clay Allen from Mosaic, and he is going to be talking about implementing best practices in motor greasing. He's got a great story to share. They're doing a lot with their lubrication program at his facility. So he's going to be able to share, their journey and the success they've had. What's also cool about this presentation for those of you who might be considering coming down to our Ultrasound World Conference is Clay is also going to be talking about this down there. So he's agreed to be one of our presenters. So this will give you kind of a flavor of what you can expect as far as content and hearing from peers of yours sharing their knowledge and information. So keep that in mind, and Clay, we're thankful that you're able to do this today for us. So thank you. Oops, let me get my screen working here. So before I turn things over to Clay, just a couple housekeeping items. Clay said it was okay for us to record this, so just like we usually try to do, we are going to record it, and I'll get it up on our website this afternoon. So if you have anybody that needs to hear this story, you'll be able to share that link with them. Or if you have to hop off, certainly you can catch what you missed later. So keep that in mind. And then if you've missed any of the other lubrication topics we've done this month, those are already online. So check those out, and definitely email me or give me a buzz if you need help finding those, and I'll get you hooked up. And we do welcome questions, so just type those in. I'll be keeping an eye on those throughout Clay's presentation, and we'll have some time at the end for some Q&A. So don't be shy. Definitely pop those over to us, and we'll get to the ones we can, and we'll certainly follow up offline if there's anything that makes more sense to have a phone call about. So also, just like to always remind, we are doing this live. So if we experience any audio issues or internet slows down or anything like that, just kind of bear with us. We'll jump and try and get things resolved as quickly as we can. So with that, I am going to turn the screen over to Clay and just give us one little moment of transition here, and we'll let Clay take it away.
All right, is that good, Maureen?
Looks great.
Okay. Welcome, everybody. Appreciate you all attending. My name is Clay Allen. I am a mechanical reliability engineer with the Mosaic company. The facility I work at is our Four Corners mine located in Central Florida. This is my first webinar, so please have patience. As Maureen said, we run into difficulty. For this presentation, I don't claim to be an expert, but I do have a lot of experience working with all kinds of motors, different manufacturers, frame sizes, horsepowers, applications. This presentation is a collection of the best practices that I've gathered throughout the implementation of our motor greasing program. And we've gone through a lot of different growth spurts, right? You kind of do a couple things, you hit a plateau, you find more information, you implement it, you keep growing and growing like that. So I'm glad to bring this to you today. And if you see anything that is not included that you had as the best practice, I'd love to hear about it. Love to hear from you, because it can help us grow and increase our manufacturing ability, as I hope this presentation does for you. With this presentation, I truly set this up for it to be for you. I tried to keep it very broad, covering as many topics as possible so that everyone can get something from it, no matter your program maturity level or if you're even looking to start one. This is not set up to be a look at how good we are kind of presentation. I really want it to be for you and help you get better, because I want you to be better than us. I don't want you to be Mosaic Four Corners, because you're not. I want you to do some R&D. Everybody knows what R&D means: rip off and duplicate. Please do not copy and paste. I mean, there may be some things that you can transfer directly over, but again, make it as applicable to your company, your facility, your culture, and your personnel as possible. Best practices are best practices no matter where you go. But please make it as specific as you can to your people. That way it'll actually stick. Maureen said use the question form so that the presentation will be even more beneficial to you. If there's something that you want to need some more details on, we can cover it then and there, or we'll cover everything at the very end. And again, feel free to contact myself or UE Systems for further information on these topics. The presentation is being recorded. I'll be glad to send this to you in a PDF. I do have approval to share outside the company. At the very end, I'll show some already written procedures that we use. I'll be glad to send those to you as well. I have some world-class standards pages which will cover the presentation. I'll be glad to send those to you as well. So again, I really tried to gear this towards you as the audience and making you guys better than us by kind of streamlining and getting some of these best practices out there for everyone to use. Just wanted to include a couple slides about us as the Mosaic company. We're a Fortune 500 company. We are in the crop nutrient business. Basically, we make fertilizer. Our mission is to help the world grow the food it needs. And when you look at our principles being here, responsible, innovative, collaborative, driven, there's a lot of different things that you can pull from your company statement that you can work into your motor greasing program. And it's always great to see the high-level goals from your company worked all the way down into the site where you're actually getting the work done, creating value for our stakeholders, growing and strengthening our business, and developing and engaging our people. A lot of mechanics our average age. A lot of mechanics is about 55 years old. We are at Four Corners. We are a union facility. All of our mechanics do the motor greasing. May be different for your company, but still the same. As we got an aging workforce, but when you try to roll out new technology, there's always a little bit of barriers. But there's a lot of things about ultrasound that is very easy to pick up and learn. Mosaic is a collaboration of all the phosphate mining companies that have been in Florida for the past 100 years. So Central Florida has a rich phosphate deposit, and it's called Bone Valley. They've been mining it since the 1890s, donkeys and pickaxes and pull carts, but we've upgraded since then, obviously. We did about $7 billion in sales 2016. I haven't seen the 2017 numbers, but we had in about 10 different countries, about 9,000 employees join operations. We have most of the phosphate side of the business is in Central Florida and a couple plants in Louisiana. We have the potash side of the business up in Canada and some in New Mexico. About half of Mosaic's sales are the North American market just due to the location of where we are mining and creating the fertilizer at. I go through these slides just to kind of show you that we're not a little mom and pop place. We have the same struggles as any big company. You got competing initiatives, you have tight budgets, you have the desire for reliable equipment, you got safety, you got environmental, and all these different things that you need to consider. But even amidst all that stuff, you can still easily take care of your equipment using ultrasound and some of these best practices. For the phosphate mining side of the business, we use drag lines, surface mining. They dump the matrix into a pit where there's two water guns, create a slurry, and it's pumped all the way up to the beneficiation plant. We're pumping about 13 miles right now. We have one pump per mile. Comes all the way up to the beneficiation plant where we basically sort what we want from the stuff that we don't want. Obviously, we keep the phosphate rock and we send everything else back to the field for reclamation. I've got a picture of the beneficiation plant right there. So it is really true to the mining. And once we have the phosphate rock, we send it to our concentrate facilities. They keep it on a pile here, and we are the world's largest purchaser of sulfur. We make our own sulfuric acid and mix it with the phosphate rock, add some ammonia in the granular plant, and finally get our crop nutrient product as our finished product. Crops need three minerals: nitrogen, potassium, and phosphorus. Here in Florida, we have the nitrogen, the ammonia, and the phosphorus from the phosphate rock. And on the other half of the business, the potash side, up in Canada is where the plants get the potassium. So you can't buy Mosaic products in Lowe's or Home Depot or Walmart or Ace Hardware or anything like that. Industrial grade fertilizer, if you put it on your yard, it'll completely burn it up. We're mostly corn and soybean, large scale farming. My role specifically for this company is in the beneficiation plant of the mine. There's another reliability engineer that handles what we call the field, where the drag lines, the tips, and the matrix pumps are. But mine is, as soon as the matrix leaves the pipe from the last lift pump going into the plant, it's mine until it leaves the site. So all the rotating equipment that the matrix and tails will touch inside the plant and leaving the plant, I take care of that. So pumps, conveyor belts, all the associated motors, the float cells, log washers, the trommels, the vibrating screens, a little bit of the structure, but there's a lot of different things that we use to move and make phosphate rock. We're about 2 years into our motor greasing program, and I oversee 365 motor lubrication points. That's just motor lubrication points, right? If it rotates, I honestly can tell you I've tried to put ultrasonic sensor on there. We have them on our conveyor belt, pulley bearings, pillow block bearings. We have them on our log washer, pillow block bearings on the tail end. We have them on our trommels. A lot of that stuff is slow speed, 8 RPM for the trommel and about 50 to 100 for the conveyor belts. We had good success there, and that's another presentation for another time. As far as certifications, down here, CMRP, MLA2, MLT1, which is the oil analysis kind of stuff, 5 Category 2, Ultrasound Level 1, FE from the state of Florida. Not trying to boast or anything, but what I'm trying to show is that you got to have a kind of a comprehensive view if you really want to truly understand how to take care of your equipment. Equipment is always talking to you. It's the matter of, are you listening? Are you picking up on the little things that telling you that overloaded is underloaded? Does it have the right kind of lubricant? You got everyone know a lot of emphasis put on PDM vibration and things like that. I also want to start with kind of explaining why I really enjoy talking about this subject. All what you see on the screen is the P to F curve. Won't take too much time to go into it. Hopefully it's common for you out there listening. But point P is where you have the point where a defect occurs. Where you identify it falls hopefully somewhere along this top part of the curve, and you catch it really before it fails. So you got ultrasound and vibration, you got where to bring your oils, thermal anomalies. This is your predictive maintenance, domain, your PDM stuff. And your reactive failure is when you can do nothing but replace it. Of course, your repair cost increase. So there's really a whole left side of the graph that really doesn't get shown. If this is point P where the defect occurs, how does the defect occur? Well, you installed the asset, right? You're running it, right? So when you have this I to P interval, you want this line to be as long as possible. You want this to be decades and decades and decades. You want to install the asset and run it and never have a defect occur because you don't want to ride this train because it ends in catastrophe, right? So what we're talking about today is precision lubrication. There's a lot of things you do to the asset after you install it so that a defect never occurs. Because this I to P interval, this is where you make the money. Right? You're running it, you're doing a little bit of maintenance on it, but you're never really going and riding this all the way down to failure. You got routine equipment care, PDM, precision maintenance. What we're talking about today, precision lubrication. I to P again is where you make the money. And so that's really why I'm passionate about this subject, is because we've seen the results. And I like to share as many things as I can do to show you guys today that can help you achieve some of the same results. And honestly, make your lives easier as far as having to do less RCAs, having to do less reactive maintenance, and moving forward so that you can focus on a lot more detailed things. I want to cover a little bit about where we started. We have a third-party PDM vibration vendor that does monthly checks on all of our equipment. Years and years ago, not too long ago, actually probably 3 years ago, before we started the program, we were completely reactive. So you can see here they do their monthly checks going along, and all of a sudden, whoop, you got a high point. And then in this G's graph down here, the time waveform, completely indicative of lubrication issue. Raised noise floor, very erratic, high G's all the way up to 8 G's on this motor bearing, as you can see in peak view. So basically, we were having a third-party PDM vendor saying, hey, you should put some grease in this motor bearing because I'm seeing vibration signatures that indicate lack of lubrication. So we were past this point P, we were out here, increased vibration amplitude. We weren't in this IDP interval. We had gone past this, and the equipment was telling us, I'm starving for grease. The vibration was actually putting it up, and someone else saying, hey, you should probably go grease to it.
Hey,
So that's
Clay.
where we, yes.
Sorry to interrupt. Hey, I think every once in a while you're getting a little kind of muffled, so I don't know if you're moving your phone around, so just wanted to point that out. Sorry.
I'm a little bit. I will do a better job of that.
Okay, thanks.
Okay. How does it sound now?
That's good. I think it's when you kind of move the phone around a little bit. So,
Yep. Sorry
okay.
about that. Thanks for the
No,
feedback.
no problem.
So we were completely reactive in what we were doing. And the PM mechanic owned the motor greasing. So this is an example of what we had going on. He would write in grease pen on the motor when it was greased. There's a lot of questions that leave you guessing. Like, this was 2013 and it's 2015. Has it not been greased in 3 years? How much grease did he add? What kind of grease did he add? How many shots did he put in? There's a lot of unknown. But whenever you leave it up to the individual hourly employee, your salary, or whoever's doing the motor greasing, mechanic, electrician, this is pretty much the best they can do. They have a log, whether they write it on the motor or they keep it on a PM sheet on a piece of paper somewhere. They're the only ones seeing it usually. And then you have my favorite, what about when the numbers wear off? Greased October what? You don't know. And then the same questions are still there. How much grease and when did you do it? And has it been done since then, et cetera, et cetera. So getting into the best practices, just kind of a laundry list real quick. Only grease the motor while it's operating. You want to give the grease time to move around and get evenly distributed all throughout the bearing. Obviously, keep your stuff clean. Whenever you can, use a manual grease gun. You can feel the resistance, and you know when to stop. With a battery powered, it's going to overcome that resistance and push that grease right in the bearing no matter what. And always add grease slowly to the bearing. You can add grease very quickly with a manual gun, or but with a battery, always be careful not to pull the trigger and just leave it going. Couple failures here.
Hey, Clay. Sorry.
Yeah.
Just a couple people are kind of commenting they're having a hard time hearing, so I don't know if there's a better way to hold your phone, because some of the times it's perfectly clear, but then I don't know, as you're moving around, obviously, doing your presentation, it's getting moved. Okay. I'm sorry.
No, it's all right. So always slowly add grease to the bearing. A couple failure points here. What can happen whenever you don't? Dislodge bearing shield, failed bearing cage, and of course use an ultrasonic sensor to listen to the bearing of this type and needs lubrication. We'll cover that more in the presentation as it goes on. Next few slides, and the majority of it of this section is going to be on cross-contamination, just because you have so much potential for this to happen. First off, you got to use the right kind of grease. You'll see throughout the presentation some of my screenshots. We use Shell products. Not really advocating Shell, but everyone has their grease manufacturer or service provider that they have. Always consult with them when you're thinking about standardizing and have a question on what kind of grease is the right kind to use. Great picture here where someone added white grease on this Zert cap. You got red grease oozing out the seal. Obviously, they're incompatible. What you can get is the oil washout, which is what you see here. You can get hardening to where no grease will get into the bearing. You can have it completely harden up inside the bearing. There's a lot of bad things that can happen when you start to mix greases. Really what this comes into is whenever you get a new piece of equipment. So in the past, we've of course bought some new different style pumps from different manufacturers, and it'll come in from the factory with a different kind of grease than we have on site. So there's always that MOC process that you should go through of realizing what's going to come in, what are the requirements, what's going to be the RPM, the application, and then work with your current vendor to figure out what kind of grease you should use. And there is some consolidation opportunity, but it's just something you need to work through. To help you find and use the right kind of grease and prevent cross-contamination, I would strongly suggest creating a coding system. This is ours for an example. First, you start out with the thickener type. Then you have the NLGI grade, viscosity, mineral, or synthetic. We here at Four Corners we use all minerals, so it's always going to be an M there. And then you have the additive package at the very end. So as we go through each of our equipment types that use grease out here, it's always good to create a chart. I have a chart like this posted in every mechanic's break room. We got three crews, and it's going to have a picture of the equipment, the coding program you see right here, the name from Shell, and then a grease cap color code type. And so that's what I would strongly suggest, is get you a color code system along with a naming convention so that you can prevent cross-contamination by specifying what goes where. Anytime you have two pieces of equipment that use the same grease, always list them twice so that everyone knows. And with this comes the easy accessibility to these grease caps. So this is a picture from our lube room. We have the blue zerk caps, the red zerk caps, the red button head caps, the green, the yellow, the black, the white, all corresponding with the picture previously shown. So that if these break off, if they dry rot, if they get dropped, any mechanic can come in here and grab them and replenish them on the equipment, so that just like you have oil tags on, you should have oil tags on the equipment, you can use color-coded caps to do exactly the same thing. You can also use grease fitting types. You got on the left side, you got zerks. On the right side, you have button head fittings. This is a picture of the button head cap, the red at the very bottom. Most of what you'll see is zerk caps, but if you have, for instance, all of our motors take zerks, none of them take button heads. All of our conveyor bearings take button heads because it's two different kinds of grease. That's a good way you can help prevent cross-contamination of whatever fittings on the grease gun. This grease gun is only used for, X, Y, Z type of grease. Speaking about these red button head cap fittings, they also work great on your BNC connections for your permanently mounted ultrasonic sensors. This is one on the pump. Of course, it runs behind the guard. Keep the rainwater out, keep the dust out, so that your BNC connection always stays nice and clean. It's one of my favorite slides. Color-coded cap, you can see the amount of contamination we deal with on the pump. This is actually the shaft side of the motor. And I promise you, I did not doctor this next picture. All I did was pop the blue cap off, and that's exactly what was sitting underneath. And you see the contrast from the amount of dust and dirt and junk in the atmosphere to what your cap actually does for you. You may have to wipe it off a little bit to see what color it is, but not only is it protecting you from cross-contamination, but also your regular contamination as well. And a lot of people say, I don't really need a color code cap because I just leave a dollop of grease on the fitting. And to that, I would just reference this picture where every 3 months you're going to come around and grease something. Usually that's our frequency for greasing motors. What kind of grease is that? Is it providing any contamination protection? It's definitely not, because your ball check is exposed. There actually should be a black zerk cap that goes on this fitting because it's a 100 weight grease. So when the grease is a brown caramel color, you don't really know what kind it is. So a dollop of grease will get you by in a pinch. If I have a pack in my pocket of grease caps and I run out when I'm greasing motors, I'll leave a dollop of grease, but by the end of the week I will come back and put a cap on that motor, just because of the amount of protection it provides in our atmosphere, in our conditions: hot, humid, dry, dusty, windy, outside, all that stuff. Another thing that you can do with your grease guns, whenever you start your program, I highly recommend going through what I call a grease purge, which is pun intended. Right, so I will go to each of the mechanics, mostly the PM mechanics, and I'll just say, hey man, I know you have grease tubes and guns hidden out throughout the plant, and your toolbox is upstairs and any rocker downstairs. Show me what you got. And so we'll go through, and if the grease gun was in good, clean, working order, we'd color code it. If it was in too dirty or didn't really function right, we'd just get them a new one. And then it would be color coded for whatever kind of grease they wanted to use. Also, going through the flammable cabinets and the cabinets around the shop, you'd find grease that we don't use anymore. It's a synthetic grease, or it's the old kind of motor grease that we used to use. We just grab those and dispose of it. And then it's a great way to make sure that no one just grabs a tube because they can't find anything else and starts putting it in a piece of equipment. On the right here, you have these. Lincoln sells these for Zerk couplers. Excellent item to, I know those always seem to break off or get lost. You can buy some replacement ones. Keep your grease gun nice and clean. So as far as color coding, very simply, on the left side of the screen here, you got my first thought was to wrap them in electrical tape. So I bought a multicolor pack of electrical tape for $10. And so that's what we started doing, was just wrap the tube in red. Red happens to be our 220 grease. Then I was out at a conference and found these clear tubes that you see in the middle of the screen. That lets you see exactly what the grease tube says. This is our 220 grease, our coupling grease, and our motor grease. So not only are the tubes color coded, but are nice and clear, so you can see exactly what the tube says, so that as you replace the tube, you know exactly where it goes, and on to help you prevent cross-contamination. One of the biggest things I find whenever you're making improvements like this or starting something new is no one in your facility really has a true understanding of what does good look like. Because what we always do is compare ourselves to ourselves. So we say, oh yeah, we're better than we were 3 years ago. Well, that's great, but where should we be at? What is best in class? What does world class look like? And that's why I created these just 8.5 by 11 sheets of paper that have pictures of our equipment that tell the world-class standards for electric motors, world-class standards for grease guns. I got some for gearboxes, for hydraulic units, for oil filter units, for conveyor holdbacks, for bulk oil tanks. I got everything that we want to do regarding lubrication. What does good look like? And so the intent of this is that anybody can take this piece of paper, walk around to any motor in the plant. Doesn't matter if it's a washer, the size of the float plant, the conveyor, the dry rock loading system. Doesn't matter the horsepower, doesn't matter the RPM, doesn't matter the OEM, doesn't matter the size, anything like that. If it's a motor, it will have these things on there. No exposed wiring, conduit in good condition, fan in working condition, color-coded grease cap, and in some of our vertical motors that are oil lubricated, they're going to have a tag on there. Anybody can take this, walk up to anywhere in the plant, and find the motor, and it should have these things on it. And I did the same thing for grease guns on the right. So definitely, I would encourage you to. I'd be glad to send these to you if you want them. Just send me an email, and I'll send you what I have, and obviously make them applicable for your situation. But what does good look like? It's hard for people to understand that. But when you get around to using pictures of your equipment, everyone kind of starts to say that this is doable. We can reach this goal. We can be better than we were 3 years ago, but still keep pushing towards perfection. So there are a couple slides about ultrasound. Of course, ultrasound is the best practice. It is lubrary, right? So what I tell people a lot of times when I'm training them for motor greasing is that ultrasound, all it does is just measure friction. Not enough lubricant causes metal-to-metal contact. Too much lubricant impedes the movement of the rollers or causes them to slide, which creates even more friction. That's why your dBs are high before you grease, and that's why if you put too much grease in, the dBs go up. It's just measuring the amount of friction. But the correct amount of lubricant generates the lowest possible amount of friction. And on top of that, the user can trend the decibel level, the dB level, and track the condition of the asset. Helps prevent lubrication-related failures, reduces grease usage, which we'll cover later. But the biggest thing is it's condition-based lubrication versus time-based. Instead of telling someone to go add 10 shots every month to this motor or to this piece of equipment, ultrasound allows you to see the dB reading, make a decision, listen to what the bearing is actually doing, and determine if it needs grease. And if it needs grease, it lets you know exactly how much grease. Maybe it needed 20 shots instead of 10. So while you think you had good maintenance practices of, yeah, we greased that motor, but I wonder why it's still roaring, or I wonder why I'm still getting PDM work orders on it. Ultrasound allows you to see past everything and inside the bearing of what it's actually doing. Give the bearing exactly what it needs, because like I said earlier, the equipment is always talking to you. It's a matter of, are you listening for it? Are you watching for what you need to see so that you can help, and so that you can help extend the service life? Ultrasound is the best practice because it helps prevent over-greasing of bearings. Like I said earlier, if you have a PM to go add 10 shots every month, but it really only needed 4, those extra 6 shots, they have to go somewhere. Each stroke of the grease gun's got to go somewhere. Listening with ultrasound tells you when the bearing has a sufficient amount of grease, or if it needs anything at all. Best practices for mounting your sensor. We usually use the magnetic sensor. Sometimes it's hard mounted if it's behind the guard, but most of our stuff, especially in our pumps, you can get to. There's a couple inaccessible motors that we have. We'll cover that later. You only got 2 bearings, your opposite drive in and your drive in. In other words, your ODE and your DE. The angle that you put your ultrasonic sensor does not matter. Always use a clean surface. Wipe it off a little bit. If you have any chipped or peeling paint in an area, don't use that area. Use another one that's nice and smooth. And always use the same location and mark the spot for future readings. So when we went through and started our program, of course, you establish a baseline first. And when we were doing that, of course, we carried a grease gun or ultrasound gun, and we carried a drill. We had a sufficient size drill bit. We just drilled a little divot in the frame of the motor wherever we wanted to consistently take a reading from. And we could use paint, you could use magic marker, whatever, but I mean, it's Central Florida. It rains a lot. The sun is intense. All that stuff is going to fade, but you're not going to fade a divot from a spot on the bearing. So I would definitely recommend that. Make something permanent so that you can always get consistent readings from the same spot. Of course, do not put the sensor on the fan shroud, the cover, the cooling fin, or any debris or buildup, because you're just going to mess up your data, and you're not going to get a true, accurate reading of what the bearing is doing. We do have a couple of these motors, great for contamination, right? All the fins are covered, but how are you going to get a reading on this opposite drive-in bearing on the fan side? There's always a spot that I call the belly of the motor. That's what I call it. I don't know if there's a technical term for it. Right above the base bolt, there's always a nice smooth spot where you can get to the opposite drive-in bearing. And even on this previous slide, you can see it here in the bottom left. If you have fins all the way around your motor, there's always a spot right above this base bolt next to the fan shroud. Don't put it on the fan shroud, but there's always a nice flat spot right there at the belly of the motor that you can get to. And this is probably my favorite slide of the entire presentation, just because you don't hear much about the results of using a condition-based system such as ultrasound. And I've examined many different manuals from U.S. Motors, from SKF, from Shell, from GE, from Siemens, from Dodge, to Baldor, Toshiba. After a while, all those manuals start to say the same thing, and really what they're trying to do is cover all the products in every application. And that's a great starting point. What does the OEM recommend we do to their motor? But it's not really specific to your application. And on top of that, does an OEM do your rebuilds? And in our case, at Mosaic, they do not. We use a local shop who's certified, but they're not the OEM. So if their OEM puts SKF bearings in and our rebuild shop puts Timkins, what happens to your calculation? You know what I mean? It can be thrown off if you just use a PM planned basis for which to grease your motors. And chances are that over time, what your OEM says in the manual isn't going to exactly match up to what you have in the field. But that's the beauty of ultrasound, because it doesn't matter what size the bearing is. It doesn't matter what brand. It doesn't matter what RPM. It doesn't matter what frame. Every bearing is unique. You can have 2 bearings on the same motor, same exact bearings, they're going to run different dBs. But ultrasound allows you to set a baseline and compare the bearing to itself time after time after time, and it lets you ensure that you have the proper amount of lubricant. All that rest of stuff doesn't matter if you give the bearing exactly what it needs. And that's what this spreadsheet shows. This first slide here is a picture of our route from our conveyor motors. We had a third-party lubrication service company come in and they did the calculation on all of our grease lubricated equipment. So you see here in this center column where it says planned strokes, this is the amount of lubricant that the calculation said that we should put in our motor every 3 months. This is the actual strokes I used with ultrasound. Or the PM mechanic used. And honestly, you'll see a lot of zeros. But what you'll see whenever you see numbers, you'll never see this amount. Needed 78, I put 23. Needed 62, I put 15. The other side needed 62, but I put 9. So what you get is a little bit of grease savings, but grease isn't all that expensive. But just think about the time and effort that you save. So for this route in December of 17, planned at 2,800 strokes, only did 315, saved $30 worth of grease. So our maintenance budget at Four Corners is $50 million a year. We're the largest phosphate mine in North America, and I saved $30 on a lubrication route, right? Big deal. But it is a big deal because I can honestly say I went and checked every motor bearing on our conveyors, and they all sounded great. If they needed grease, I put the exact amount of grease that they needed for them to continue trouble-free service for the next 3 months until I check it again. So it's not just about grease savings. We always want to show some sort of cost savings, but it's all about the time that you would need to put 78 strokes in, and does your equipment actually need it? Here's another slide, $193 of savings for this route. It's a longer route, and the float plan on our floor for our motors. You'll see some of these big boys right here. 1,000 horsepower motor, 252 planned shots of grease. I put 13. 252 planned shots. How many I put? 0. So you get $4 worth of grease savings here, but again, it's not about the grease savings. It's about giving your equipment exactly what it needs, giving each bearing exactly what it needs. So for 2017, I mean, about $2,000 worth of grease savings, right, out of a $50 million maintenance budget. Big deal. But it is a big deal, especially whenever you look at how many zeros just end up lining up right here in this actual strokes column. We've been at this for 2 years, and probably about our fifth and sixth time in, which would be about a year and a half, I started to notice, man, I'm not greasing these like I used to. So what you'll see is if you track your actual strokes, it'll actually be less and less and less year after year, because as you get to that precision stage where your bearing is good, all you need to do is just replenish a little bit of grease here and there. You're going to find yourself doing less and less work. Yeah, it is some upfront work to establish some of these best practices to help prevent cross-contamination, to set up your lubrication route, but at the end of the day, you're going to be doing less work in the long run. And that's really what I wanted to show, and I haven't really seen with any other lubrication or ultrasonic motor bearing lubrication stuff, is somebody actually tracking planned versus actual and showing that you're going to use less and less and less time after time. This is the most fanciest slide in my whole deck, right? That's a joke, but I did want to include something about VFD motors. So for VFD motors, we have a handful. We do it on a PM basis. So we will use the 10 shots every 3 months, but that number comes from similar sized equipment and similar applications that we use ultrasound on. So if I know that I'm adding about 10 to 15 shots, maybe 20 shots of grease to motors, and I can verify that with ultrasound, I'll use that as a starting point for greasing a VFD motor on a PM basis. Otherwise, another thing you can use is a PDM, your PDM vibration guide. They can look at it in high frequency. As long as you can get the motor to stay at the RPM for a couple minutes, they can look and see if it has the indications of needing lubrication. You can do it that way. But I've tried different sensors, different frequencies, all things I can think of to try to overcome the noise of a VFD with ultrasound, and I just can't do it. So it's the 100 or something of you guys out there listening right now. If you guys have a way, please let me know, because I'd be glad to implement it. We'll talk about inaccessible motors for a little bit. That's great if you can walk up and put a sensor on it, but we have a lot that we cannot. So this is a Wimco float machine where we float our concentrate product. And you can't reach it from the handrail. You can't reach that top bearing. Of course, it's belt drive, and you're always going to have to add more grease to a belt-driven motor than you would for a direct drive. And it was just hard to take care of these motors. They're only 30, 40, 60 horse motors, but still we're going to take care of them. So what we ended up doing was adding remote lines that can be reached from the walkway, and we do these on a PM basis. So we do not do these with ultrasound. But we are going to take care of them. We're going to take care of them in the easiest way possible, and the most beneficial for us. So what will end up happening is the P mechanic will lock out the paddle, right? This paddle set right here, right above the handrail. It'll lock this out, and while the rest of the machine is still running, he can reach over, connect his grease gun to the grease line, and cruise his motor in the best way possible. This piece of machinery is called a log washer. And for whatever reason, whenever they built this plant in 1981, they did not put any kind of walkway to get out to the motor, gearbox, belt drive, anything like that. It's hard to check oil level, hard to check belts. Anytime you have to do any work, you got to put on fall protection, climb out there. It's a bad setup, and we have 16 of these. So what we ended up doing was installing, again, remote lines that you can reach from the walkway. But these are 200 horsepower motors. They're part of our repairable spare program. So we decided we're going to use a PDM technology on this. We're going to use ultrasound. So to each bearing, you can see we ran ultrasonic lines as well as grease lines. Put it in a weatherproof box right here at the handrails. So on the right, you have your B&C connections on top. You have your corresponding grease line that goes to that bearing on the bottom. On the right side of the box is the fan side bearing. On the left side of the box is the shaft side bearing. So very easy to connect up, listen to it while the equipment's running. And it was a big safety reduction from having people get outside the handrail to add grease to this motor. Getting into some procedures, the best thing to do is always write stuff down. We have a baseline procedure here for motor greasing. We also have a PM procedure for motor greasing. We have how to use the UE 401, which we'll cover in the next couple slides. But they're all written in structured writing format, and the first thing you do is always establish a purpose. So if you try to wrap up too many steps in a procedure at once, it's going to be hard to follow, hard to get feedback on it. What you want to do is break it out as much as you can. So this is just for establishing a baseline, but a lot of them read the same. We'll go over that in a second. But just going through these basic instructions, they have a lot of best practices wrapped up in it. So you establish at the beginning of your motor greasing program and reestablish whenever a motor is replaced. If you have any PM guy worth his salt, his or her salt, they're going to know when something is replaced in their area. And they come to me and they say, hey, I need this replaced. I need to get a baseline, because we're also going to do a PDM baseline on it with vibration. A lot of times you want to do your ultrasonic motor greasing before they do a PDM vibration on it. That way everything is good. So whenever I'll load up a route, I'll go out and get it and put it back, and then in the UE software, I'll make that the baseline. Of course, these procedures are only to be completed when the motor is operating. The dB starts to increase at any time. Stop greasing the motor. That protects you against over-greasing. This next one is somewhat controversial depending on who you talk to. And again, this is just based on my experience with all of our mining equipment, is to do not add more than 20 shots of grease to a bearing. And I preface that with saying that this is not a hard stop. This is a stop and think, because if I sit there and keep adding grease and the sound does not change, there's a lot of things inside a motor that grease isn't going to fix. So this is more of a stop and think. Is adding more grease actually going to help my problem? A lot of times the guys will call me and say, hey, I've been greasing it, I've hit my 20 shots, and nothing's happened. Right? It sounds like it needs grease, but I keep adding grease and nothing happens. So a lot of times I'll go out there with them, and I'll listen to it, and I kind of verify, use it as a teaching moment. Say, yeah, this does sound like that. Let's add a little bit more. So we'll do 5 shots real slow, and then we'll do another 5, another 5. And sometimes you get to 35 or 40, and then you get that sound change. So that's always just to kind of protect you against adding too much grease. And it's really just a stopping thing. So I encourage you to have, whether it's 20 shots, 10 shots, or 40 shots, or whatever, always kind of have a stop and think section here for, is adding grease really going to help this bearing? Sometimes we add grease just to remove crackle. Sometimes we add grease just to lower the dB rating. But the more and more you listen to the bearings, listen to the motors, you'll be able to distinguish what's what. So I always encourage you to not necessarily have a hard stop. If you want to, you can, but always have a stop and think. Of course, we're putting about the purge plug. If you can, remove it and make sure that it kind of flows out, get that old grease out of there rather than going into the windings or anything like that. So this next page is just a screenshot of the if-then statements and what to do. And I'll be glad to send these to you for a jumping off point. Just let me know. So the next we have the motor greasing PM procedure. So that previous one was establishing the baseline. This is what we follow every 3 months. Again, you'll see the basic instructions are pretty much the same. Start to increase, stop greasing it, always do it when it's running. There's actually 20 shots in there. And we'll talk about purging for a little bit. We don't really purge motors unless it's necessary, because it's a lot of work. A lot of times the purge plug's behind the guards. You have to lock it out. You have to do all that stuff. but we will do it if it's what's right for the equipment. And so that's why I put in here, if you want to purge something, don't take it on yourself to do it. I always tell the guys, get me involved. We'll talk to the supervisor, and we'll get a good plan together, and we'll do it. And from our establishing a baseline and looking at our PDMs and getting our program started, I've probably purged about 4 motors, and they usually come back with great success. Sometimes the motor's been neglected for so long, you have to get that old grease and thickener out of that motor to give you a fighting chance going forward with establishing a good program. So I would encourage you to always give your guys that option and empowerment to make their own decision as far as I think we should grease this, or purge it, but always have a sound check, right, to bounce it off somebody and see what they think. And we always get the before and after reading here, this last bullet point, get the before and after reading so that we can track how much we're adding. If we keep having to add more and more and more every 3 months versus on similar equipment we don't, if we have a seal going bad, or it gives us a good way to check and make sure that everything is functioning as it should. Here's just a screenshot of a couple of steps, the if-then statements. We use the 8 dBs or more for greasing. The cutoff level, again, I'll be glad to send these to you as a jumping off point, but please make them applicable to your area. So right now we have 7 PM mechanics that grease the motors in their area. We really approach it as we're going to empower everyone, we're going to teach everyone, we're going to give everyone absolute control over the equipment in their area. Motors, gearboxes, everything. So I wrote up a little how to use the 401 sensor. I also have one on how to use the 9000. If you guys want that too, I'll send it to you. Just quick screenshots from UE's manual. Made my own right here in the bottom right as far as what each icon on the screen is going to tell you. Of course, we always check our calibration before the gun goes out to do a route using a Wobble tone generator. I epoxied a washer on the side, pick up the structure born, and I believe it's at 11 dB for our instrument. So if it reads anything other than 11 dB, maybe put in an offset or send it off for calibration. They do get well used out here. And just how to obtain the dB reading, and all these procedures wrap into each other. So you'll see going back a little bit, reference down here how to use the 401 ultrasonic sensor procedure, because in the motor greasing, it's going to tell you attach the ultrasonic sensor. Well, how are you going to do that? Well, in your training for how to use the sensor, it's going to tell you how to do that. So they all wrap into each other and really work well. And of course, you got to write it down, because I can get moved, I could get hit by a bus, a PM guy can move or get promoted or this and that. You have a lot of turnover. Always write something down, that way you can have a training point to go off of. And with that is the end of the presentation. So is there any questions?
Awesome, Clay. That was really great. I always prefer when I hear people say, instead of getting hit by a bus, let's be a little more positive in case you win the lottery, right? That's better. We don't want to think of a world where Clay gets hit by a bus. Okay. Yes, we do have questions, so let's get to them. Let's see. First off, did you calibrate your grease guns to ensure consistent amounts of grease?
Yes, I did. We have a metallurgical lab on site. They have some nice scales that read out to thousandths of a gram. So I took a grease gun. I have one grease gun that every PM mechanic does their motor greasing with, and I keep it in my office. And I, of course, loaded up grease in it, and I did 10 shots and weighed it, and I did 10 shots and weighed it, and I did 10 shots and weighed it. So I did 3 sets of 10 shots, and I took an average. And that's how I knew exactly how much stroke would give me, and that's what I put into the software to calculate my grease usage.
All right, awesome. So then talking about, you mentioned the software, so someone was asking when you were showing your reports that you had pulled, for all the zeros that you had on your actual strokes column on that report, they want to know, how often did you check those bearings to ensure the lubrication was holding up, or is that even something that you did recommend?
Every 3 months. Every 3 months, that's the data. If I walk up to a motor and I stick the sensor on, I'm going to, if it sounds good, I'm going to press the before button, and if it sounds good, I'm going to press the after button, save it again. And that's how you get the zero strokes into your software. And it's also going to tell me on the left where it stacks your readings. You're going to have basically two readings that are exactly the same, but the times are going to be a couple seconds off. That's how I know I added 0 shots, and it's every 3 months. So walk up to it every 3 months. Now keep in mind that our PDM vendor does monthly checks on all of our equipment. So if they see something from a vibration perspective in between those 3 months, they'll let me know, and I'll grab the ultrasound. I'll go out there and listen to it.
All right, awesome. Someone else is wondering, for your inaccessible motors with long grease lines, are you concerned about how long it takes for grease to get to the bearing and the condition of the grease once it gets to the bearing?
Yes, that's a great question, something I'm working through right now. So for those log washers, those lines are about 15 feet long, and the walkway is elevated from the motor. So a lot of what I see, what I can figure out from my own mind and what I know about grease, is that the grease sitting in those lines, whenever it gets hot and cold, from daytime, nighttime, and whatnot, from the sun beating on it, that oil will come out of that thickener. And I think what happens is that travels down the tube and gets into your bearing. And so that's really what making your bearing keep going, right? Oil in the grease, not the actual thickener. But what happens is when I go to re-grease, I end up using like 40 shots to kind of clear out that old thickener and get new grease with oil in the thickener down to that bearing. So what I'm considering is doing a type of purge, maybe a relief fitting at the bottom there, or just taking it off, kind of leaving it open or running it down to an accessible point where we can take the purge off and then add that fresh grease instead of having to do 40, 45 shots on that bearing each time. So that is a great point. With those long lines, always be careful of having the oil separate out inside those lines and travel through gravity down to your bearing. If that motor was in the air, I wouldn't be as worried because the grease would just come back down to the Zerk fitting, and every time I would put new stuff in there, would carry that to the bearing. So definitely something to figure out, and wherever possible, try to make your lines as short as you can.
Okay, awesome. There were a couple people that were asking something similar to that, so that was good. Good answer. Okay, someone else is wondering, do you have a dedicated lube technician? If not, how do you handle training / knowledge base across multiple techs? So you touched a little bit on that, but maybe just kind of review that for
Yeah,
us.
when we first started out, we identified the people on each crew. We have 3 maintenance crews that we wanted to do the motor greasing, and usually it fell to the team mechanic because every motor is attached to something, right? So the team mechanic who takes care of pumps, he's got all those big motors on the ground. Well, he's the obvious choice to take care of his motor because he sees it every day and he wants to have that ownership. And so that's how we ended up training 7 PM mechanics, 3 in the washer, 3 in the float plant, and 1 on the conveyor belt. I just pulled everybody in a room. I put together a little presentation. I had the gun so that everybody could practice pushing the buttons and listening to the sensor and everything. Kind of had a little kickoff meeting. Had the procedures, gave them the procedures, and what ended up coming out of that is I would walk around with them probably about half of the route, make sure they understand what buttons to push and help them get adjusted to listening to the sounds of the bearings and understanding exactly what each sound is telling you, what lack of lubrication sounds like, what contamination sounds like, and how much of a probability you have of making that sound good again, and it's kind of explaining what the DB. So it was really a one-on-one coaching with 7 different people, and it was cumbersome. But as the more and more you do it, the less and less you have to be interactive, to kind of take it over. However, with your turnover coming about, what I found myself doing is doing that again and again and again. And so our initial approach was empower everybody, right? We want to create this, make it a culture. But what I'm considering now is having a lube crew of 2 mechanics, guys or girls, whoever they may be, whoever's best suited for the job, that do all the motors in the plant. And after doing some quick calculations or whatever, I think it's about 4 hours a month and you can hit all of the motors in our plant. And so that's definitely the way to go, because I wouldn't say have 1 lube tech. Always have at least 2 or 3 people. That way you can establish a crew and a culture. And that knowledge can be retained because you can train out 1 person, and while that other person getting up to speed, you're still good. It won't drain your engineer's resources or your supervisor's resources, whoever's in charge of your motor greasing program. So my advice from experience is always try to have a crew and never just one person, because that one person, usually if they're good enough to be a lube tech or good enough to be a planner or a supervisor or move on, always kind of have a crew so that you can kind of create a culture and, you know, make it kind of as easy as you can on the person who is the owner of the program, the coordinator of it, if that makes sense.
All right, great. So kind of back to the hard to reach spots. So someone was asking, in your experience, are auto lubers a reliable option for hard to reach lube points?
Yes, but it depends on the frequency. So like our conveyor bearings, you got the counterweight pulley that hangs all the way down and nobody can reach it. Well, of course we're going to have a lube line that goes all the way down there. But you're going to grease that a little bit more frequency, because if you want to purge it out the lip seal on the side, you're not worried about it going in windings or anything like that. We do ours on a 3 month. We do our motors on a 3 month frequency, and in some cases, in some modes, we could get away with a 6. That's kind of why I have a lot of zeros on my 3 month. Is then maybe in the next 3 months I might have to add a little bit, but it all depends on your frequency. Just speaking from us using Shell products, I know Shell has something called the Tactic Auto Single Point Lubricator. SKF has some, I know. I've looked at those as well. But it just all depends on your frequency, right? You don't want to put too much in there. And honestly, how do you know that that amount of that applicator is putting out is going to be the right amount? So yes, you can use the auto lubricator, but I would follow that up with ultrasonic sensor, right? You can have those lines be as long as you want, 100 feet or something like that. Always have your checks in there to make sure your bearing's doing okay if you automatically put grease into it.
All right, great. So we're running up against our time here. There's still some questions. So for those of you that have asked questions that we didn't get to, I will be sure to get those to Clay so he can be in touch with you. And then some of these are questions that I think, you know, our UE Systems team, we can either answer or get to someone who can. So don't worry if we didn't get to you. I'm going to take the screen back real quick from you, Clay, so I can just kind of close things out here. You had your info up there, so that's good. So hopefully people made note of your email address. You know, Clay talked a lot towards the beginning about, you know, the way they're doing their lube storage and the color coding and things like that. So that's obviously a big part of a program. So if you missed it, the first webinar we did this month was on effective lubrication storage, keeping those contaminants out and things like that. So definitely a good one to check out, especially if you're kind of at the beginning of your journey of putting a lube program together. So you can kind of build on what Clay shared that they're doing, but get some additional ideas of other ways you can improve your storage, and even there was some talk about, you know, the things you need to do with selection and things like that. So just wanted to point that out. Our next webinar, the last one of the month, is going to be next Wednesday. We're going to be talking about, well, I'm not going to be, but Eric Rasmussen from Generation Systems. They're going to be talking about lubrication, hidden complexity, untapped opportunity. So just kind of, again, building on the whole idea of, you know, if you can get your lubrication program working well, that there's going to be some definite profit benefits and down, you know, less downtime and all that. So kind of looking more at the real results of a good lubrication program. So we've got the invite out already for that, and hopefully folks are signing up and will be able to join us. Again, I mentioned at the beginning, Clay is going to be joining us at Ultrasound World in May, sharing this story. I'm sure he'll probably even have some new things to add to it by then, as they continue to do great work with their lubrication programs. So if you liked what you heard today and you like this, you know, kind of personal story of how, you know, the lessons learned and the success they've had, that's what you get at this conference. So we'd love to have you guys down to the conference. It's a great location, really good environment to get time to talk to people like Clay that are, just like you, just, get to swap ideas and bounce things off of each other. So hopefully that's something that folks will take a look at. And with that, Clay, thanks again so much. It's not an easy thing to take time out of your day to share all this information, but appreciate you doing so. And thanks to everybody for joining us today. And we'll see you next time. And have a great rest of the afternoon.